Welcome back, or welcome if you're just joining us now. We've heard in the opening panel a lot of work that has been done on the white paper, and lots of work is still ongoing. Some of the technology that the panel spoke about is super innovative, but how can we make sure that those innovations actually turn into tangible benefits? How do we make it all fit together? So we'll move into the first panel of the event now, looking at how we can move from innovation to implementation. Before I give the floor to our esteemed panelists, though, I'd like to do some housekeeping rules, please. Again, do submit questions in the Q&A tab. The panel is eagerly looking forward for your questions, and we'll answer them. The recording of the session will be available in the events lobby. Speaker information can be found on the speakers tab, so we will not be introducing the speakers with their entire bios, but you can have a read there if you'd like to. And the slides, of course, are also available or will be made available later today. So with that, I'd like to turn it over to Peter Hottam. Peter is the advisor for ATM science and technology at the CESAR Joint Undertaking. And Peter, just before I give you the floor, I'd also need to present the apologies from the colleague at NASA, who unfortunately called in sick. So some good wishes go over to her. So Peter, the floor is yours.
Thank you, Anna. Thanks very much. And certainly our best wishes over to her as well. So, but I do have with me today, I'm the moderator today. I've got three really great panelists to continue the conversation that we've heard already about the white paper. So today I've got three. I've got Tim Murphy from Boeing, Steve Bradford from the FAA, and Claude Pichevin from Airbus. So I'd like to quickly invite each of them to introduce themselves. Not a full bio, but just a quick introduction, and then we will begin.
Okay, Steve Bradford, FAA Chief Scientist for Architecture, Next Gen Development. Have done, worked with CESAR in Europe on many topics, and was one of the sponsors for the 2017 strategy. And as you probably heard, I worked on this white paper also.
Thanks, Steve. So Tim, back to you. Let's see if we can hear you now.
Can you hear me now?
Yes, we have you.
Excellent. Thank you. Yeah, my name is Tim Murphy. I'm a senior technical fellow with the Boeing Company, specializing in ComNav and surveillance and spectrum issues as they apply to air traffic management. Well experienced with standards organizations over the breadth of my career. I'm very excited to be here to speak on this subject.
Thanks, Tim. And then finally, but not least, Claude, quick introduction.
Yeah, hello everyone, can you hear me?
We can.
Okay, sure. Happy to be with you. So I'm Claude Pichevin. I'm from Airbus Engineering. I am an executive expert for CNS, and I work on this CNS item since now 38 years, which is a lot. And I'm following mainly standardization making organization like RTCA, EUROCAE, WC, ICAO, ITU. And recently I am chairing the ISNSS task force within ICAO, and I am representing ICAIA for the CNS ATM committee for the industry. Thank you.
Thanks, Claude. So I hope everyone will agree we have some very impressive speakers. So without any further ado, what I'll do is hand to Tim to take us through his point of view, how things are right now, and over to you, Tim.
Thank you, Peter. So anyone who's read the white paper knows that we've reached a level of maturity and standards where we can begin to think seriously about implementation. So what I want to talk about is the next steps once the standards are really in place, and how to facilitate that transition to real operational implementations. I think the most pressing thing that we should be doing in the near term is an operational validation phase. And what I mean by that is real early implementations that will help us understand the operational requirements and make sure, validate, if you will, that our standards are really fit for purpose in supporting those operational operations. Now that validation phase needs to be sufficient so that it can actually suss out the problems with the standards, and also be done in a time frame that any changes to the standards can be fed back to the standards or development organizations and corrected as necessary. There's nothing that will suss out problems with your systems and standards for those systems more than real operations. The other benefit of doing an operational validation phase is hopefully we'll gain enough insight into the system to ensure that it's going to scale, that it's going to meet the global needs in the long term. And if not, we can modify the plan or make changes to the standards as necessary to ensure that global standardization really scales to meet the purpose. So in order to move forward on this, we really need some committed deployment roadmaps. Now the white paper addresses this a bit in terms of establishing a high-level roadmap, but I think that we need to drive down into lower levels on that roadmap and get all the stakeholders on board to agree and have a coordinated roadmap. And that includes the air and ground service providers, as well as the operators and the airframers and all of the stakeholders associated with this. And then we need to start some trials, carefully planned trials. Again, the intent of these trials is to suss out any problems with the standards and to also give us greater clarity into the operational requirements around these planned applications. But an important aspect of this is these trials shouldn't just be one-off short-term trials. They should be trials with a plan to transition to actual standardized operations that bring benefits to the airlines. Again, trials are going to be great for sussing out deployment type requirements, end-to-end performance requirements, the suitability of those, and also the scalability and things like what happens when things go wrong, when links aren't available, when things just don't go exactly as planned. Next chart, please. So what could be some potential roadblocks we would run into? Well, one would be if we have a limited deployment of operations, if say only one region plans to implement some operation, that would really raise the costs and also slow down the equipage and ultimately hamper interoperability. If we end up with a fragmentation where different regions do things somewhat differently, and that drives any equipage differences in the aircraft, that's a real problem. We really do need global interoperability for this to be economically viable for the operators. Another potential roadback would be if we don't really have a practical transition plan. I mean, everybody should be aware that it's not feasible to have some date and say we're going to just throw a switch on this date and everything is going to transition over to a new system. The air traffic management system operates daily, many thousands of flights. We can't really disrupt that in the course of evolving it. And what that means is our transition plans really have to accommodate mixed equipage and mixed operations where we can plan for this transition period, which historically has been decades for new technology to fully be deployed across the entire fleet. Another potential roadblock is if we make this so expensive that we have limited uptake, even with, and particularly with existing aircraft. We really need to be making sure that what we're requiring can be retrofit. And finally, Another roadblock would be if we fail to identify and address those operational requirements that I talked about earlier. And fail to determine if the solutions are really scalable in terms of infrastructure, bandwidth, and any additional needs. So that's all I have to say on the subject.
Okay, good. Thanks, Tim. It's some provoking thoughts, I think, and given this need for kind of a global input, and we've got, let's say, operational validations going on a global scale. How could the aircraft manufacturers like yourself really help facilitate that and to get this input into the standards that we need to move into operation? How do you see the role of Boeing, yourself, for example?
Oh, I think we will play an important part in participating in all of these early trials and operational implementations. Obviously, we are the ones who need to equip the aircraft, or at least make the equipment available to airlines. We can act as an interface sometimes to our airline customers to help them participate in these trials. And ultimately, we have a lot of expertise in operations in general, so we can bring that to the table as these things are matured. So I think we have multiple roles to play there, but I think the more important part will really be to get all the stakeholders involved in these things as necessary, and have full transparency so that everybody moves forward or is motivated to move forward.
Yeah, so we've got the various regulators, standards organizations, aircraft manufacturers, service providers. So it's a very large group of organizations to bring together. So it's not a small task. But in particular, thinking about the standards organizations, is there something that you think really needs to be addressed as early as possible to ensure that we can move to this new infrastructure?
Well, I think the standards organizations play an important role that sometimes is not really well recognized, in that they're forums to bring all the stakeholders together. And there should be greater emphasis put on that, particularly around the operational sides. I mean, many times we have technical standards committees that don't have pilots or operators or all of the stakeholders involved and represented. So as we move towards greater clarity around standards for operations, we should endeavor to get those other stakeholders more involved at the standards development organizations.
Yeah, and I think linked with all of that would be ensuring that there's a good business case to get a coordinated investment plan as well. So I think these trials are also valuable for that, aren't they?
Yes.
Yeah. Got quite a few technology options being discussed in the paper. Does that give you any particular constraints or issues from your point of view, in particular looking at this sort of continuity of operation over a long service life?
Yeah, this is a constant struggle, that technology evolves much faster than the life cycles of our ground systems and airplanes can support. So there's been a long history of, we spend a decade developing standards for something, and then we get into the deployment phase and find out that technology is obsolete, or there's some higher performing standard. Another place we've fallen down in the past is on truly understanding and agreeing on what's required for the system from an operational standpoint. So it's too easy to get distracted when a new technology comes along that appears to be better for one reason or another in terms of performance. when our operations don't really require anything better than we already have. So I think that's all I have to say on that.
Yeah, I think in particular we need to take care. You said about the failure modes as well, but the overall resilience of the system as well is probably an important aspect. And again, that features well into trials.
Yes.
Thanks, Tim. It's a good introduction. I know, Steve, that you really want to sort of build a bit on that from your perspective. So can I hand over to you now, Steve?
Right. So and I'm going to use Tim's slide to kind of justify this. And Tim is right. These are all roadblocks that we probably put up for ourselves in this future connectivity. And being part of the group that put together the 2017 strategy, which came out of FAA and CESAR, it did lack many of these things. We had roadmaps for dates certain for when we thought the standard would be in place, but we didn't really address implementation, transition, etc. And so, for instance, the United States committed to at some point in the future supporting ATM B2 messaging on IPS. We didn't give you a date when. We basically said when there's sufficient number of aircraft for us to do things, making it very, very difficult. So I think one of the things that this white paper tried to do is try to lay out potential transitions which get around some of our major roadblocks. So for instance, what do you do with ACARS, OSI, and IPS? And basically we said, well, every one goal is for every air traffic service provider to triple stack. Another one was for every aircraft to triple stack. And in this plan, which we want to coordinate with all of our stakeholders, we kind of said, well, maybe we can get the datacom service providers to do the triple stacking for us and take the burden off the aircraft and take the burden off the ANSP, now allowing us maybe a better transition path. The other one that I go to is the limited deployment of operations in one region. You all know that the FAA went deeply into fans based on our industry input from RTCA Task Force 5. And we've been fairly successful. We got 6,000 to 7,000 aircraft or more flying around every day using fans messaging. Well, how do I then get to do the transition to ATM B2 messaging if these aircraft are still coming off the line and going to fly till 2055? So we looked at some transitions in there, and that's part of our research plan. We're looking at, can I support, sorry about that, the FAA mobile app is issuing an alert. I hope you didn't hear that. Something happened someplace. We're looking at how can we support the B2, the applications, because our controllers don't really care whether it's a fans message or an ATM B2 message, as long as the parameters and the instructions get to the appropriate aircraft. Can I support in B2 those applications I've already supporting with our controllers and fans? So we have research into that. It looks like we can. I mean, it's going to be a lot more limited than the full B2 set, but we may be able to support both fans aircraft and OS and B2 aircraft within the United States. And we're looking at that. We have research into that. So there are things we can do to use to fully utilize the technology that are around us to mitigate these single purpose avionics and protocol decisions. And so that's what that, and a lot of that is within the white paper. So I think you need to look, the white paper is not only here's a roadmap, but here's an optimistic, perhaps an hopefully not overly optimistic way where we can slowly eliminate some of these roadblocks. I did also want to comment on the very large demonstration and the stakeholders and the standards bodies. We're doing a very large demonstration of IPS. We're planning it right now. We have Boeing, we have Honeywell, we have Collins, we have satellite providers, we have ground providers, trying to prove out that the IPS works and the security functions work. One of the key things there is each of those stakeholders have brought the people who work in the standards bodies to the table to support this endeavor, because I have people who work RTCA, I have people who work AirRink, I have people who work SAE and ICAO all together. They're all part of the team, and so the results will then flow back into the standards bodies. So I think the white paper should be taken as a much more optimistic view of the future than the original 2017 strategy, where a lot of miracles had to occur. And here we're actually trying to lay out a rational way of moving forward in getting to that eventual harmonization, at least supporting in the interim the mixed equipage environment. And that's what I have to say.
Yeah, thanks, Steve. I think that mixed equipage is the inevitability, isn't it? We've got this migration from a large existing fleet. You know, I think in Airbus's case, it's OSI stack, for example, looking at IP and the transition to IP. You know, we've got the fans equipment in Europe. We've got the VDL2. There's a lot of different places we're starting from. It's good to have this conversation early to look at that forward plan and how we might make it work. I think you covered some of the drivers and choices that are really facing the FAA. But when you look at the white paper, it talks a lot about the technology options and starts to lay those out. But what strikes me is that we perhaps miss to define what the requirements are, the performance needs from this data link. It's a growing, you know, the demand for the use of greater data link is growing from many different areas, be it air traffic, ATC, or other activities, quite broad set of things. But how will we and where should we be defining the services, what the category of services and the performance characteristics around those services? What do you think, Steve?
Well, I think we tried to identify that also within the white paper, where we said, if you can specify a performance is required on the information for the application that would make it a safety performance requirement, then we should treat you differently than it's a best effort delivery of information. And a lot of the information that is admissible on our current links doesn't really have a types of performance standard around it. So it's probably fair game to move that off to a different link, like, you know, an internet link. And we're looking at that within our research program too. One of the things that was in the paper that we do have to resolve is we have protected spectrum, and we have permissible information that's on the protected spectrum. One of the things we asked, and we still have to work this out, is protected spectrum mandatory for spectrum for certain types of things, or is it just is it performance based? And that's, I think Claude's going to get into a little bit of that. So a lot of people believe that if you're currently in the protected spectrum, it must be mandatory, and that's not quite how you can read that one ICAO white paper. If you read it one way, or working paper, and if you read it the other way, it's permissible. So that's going to have to really be resolved because as you mentioned, the bandwidth usage is going up and up and up in our applications, and we need to figure out how to balance that. I think it varies by region. Certain regions may have different approaches to getting the information. So we're heavily invested in getting information from the aircraft over you know, data port EFBs and internet, if it's not it's not clearance based. And so those are the kind of research we have to do. And there's some overall policy decisions that have to be made. Otherwise, we are going to continue to run up against spectrum limitations. And we can keep trying to add spectrum, but if we can use other people's spectrum, it can happen faster.
Mm-hmm. Yeah, that's a good point. Just coming back to the standardization, just for a moment, we've got this global interoperability focus with information being at the center now, and it's about sharing it and collaborating around the information. Where do you think the standards organizations play a role in perhaps a more technology agnostic standard? Because if we, I think it was mentioned already by Tim that we quite quickly run out of time. We get technology to the aircraft and then it's out of date. So is it better to look at something that we standardize that's more technology agnostic, and we can then move from that platform more quickly, you know, within the standard?
I'd like to answer it two ways.
Yeah.
One, I'd like to say that let's not mix technology with the information message exchanges.
Mm-hmm.
I think that when we try to both specify the technology and the information in the same standard, that gets you locked up. The second thing is we're going to end up with more and more and more information standards as more and more of the things we do with the voice become data. So that's why and that means that it'll be not just the traditional technology standards bodies, but we'll get more of the OGCs, the ASTMs with the messaging, and we need to embrace that. I think from a technology perspective, we better be a little looser on writing standards to a technology we know, because every time we turn around, there's another alternative. I mean, you know, we have a SATCOM standard that was based on Inmarsat. Now we have multiple SATCOM providers, and we don't want to write one for every different type of SATCOM. So I really think that allows us to mix and match, and it's especially going to be important for us. And this is the wave of the future for like the eVTOLs and the AAMs and the high altitude long endurance. They're going to use multiple links, but they're going to have some sort of standardization of the performance on those links, and they're going to have some standardization on the actual messaging and the information they exchange. So I think what we did worked really well when we had 10 years between major changes, and as Tim said, we don't think we have that anymore.
I mean, something that we're working on very actively in Europe is the multi-link concept, where we try to create an environment where we can transition across links and technologies over time as well, and try and minimize the disruption both on the air and on the ground, and allow an easier migration across links. Early, you know, still early work, but it's a concept which we think has some potential. I don't know if you're doing anything similar in the FAA at all, or not.
Yeah, we're supporting multi-link looks, yeah. And that's within both the standards bodies and within our research.
Yeah, great, that's good. So it's a good point to transition to Claude. Claude from Airbus, would you like to take the floor and tell us a bit about this subject from your perspective? Over to you, Claude.
Okay, thank you, Peter. So just the first slide to try to explain where we are today. Maybe you know already this kind of schematic where we try to split the aircraft in three parts. The safety one, which is, I will say, reserved for the cockpit operations. Second one, which is in the middle, which is more or less used for the ops operation. And the last one, but not the least, which is for the passengers. And where we are here using what we call a SATCOM broadband system with air-to-ground system also. So we have these three main, I will say, application on board the aircraft. And for each of them, we are using, I will say, specific communication means. For the example, for the safety, we are using SATCOM L-band safety, VHF and HF, as you know very well. We are using them also to be in contact with the airline operation center. And so for the ops, we are also using then public IP communication, again, the SATCOM cockpit with L-band, and typical, I will say, all communication system, mainly on ground for sure, which are, I will say, IMT-based, international mobile telecom with Wi-Fi, cellular, 5G, 4G, and tomorrow 6G. So we have the current status for this kind of architecture on board the aircraft, which is, I will say, relatively spread over all the airframe manufacturer. Next slide, please. And then what we intend to do and what we try to describe through the white paper is to try to offload a little bit the ATC traffic as shown here in blue through the, I would say, commercial link. So the idea is really to take the benefit of those existing commercial links, which are now very well spread on the various fleet on the airlines, and to take benefit of these broadband communication systems in order to offer the opportunity to offload a part of the traffic, the ATC traffic, and also a part of the big ops traffic, which is used by the aircraft. So the idea is really to try to work on the both way, for sure keep the safety link, but take the benefit of the commercial link, SATCOM broadband and air-to ground, in order to offload the part, but also to allow the return way to use this pipe, which is, I would say, cheaper in principle rather than the ATC one. So this is the basic principle of the connectivity with hyperconnected ATM. For me, if you want, we are in a world now where the connectivity is a commodity. So you cannot have anymore now an aircraft which is not connected. And so the way you are connected to the ground through satellite or through direct air command, for me, is a key part. And so we need to propose that in order to be, I will say, still in the race of offering more bandwidth to the airlines in order to properly operate the aircraft, and also to the ATC in order to also manage properly the traffic. So next slide, please. So hyperconnected ATM is identified, as you see, as a promising concept to solve various problems for the spectrum congestion. Unfortunately, or fortunately for the VDL Mode 2, we get the COVID-19 crisis, which delay a little bit the congestion for the VDL Mode 2. Now this one is seen from 2027 in Europe. And so we need really to support the traffic growth, but also the AOC communication. We see some new application, typically engine monitoring, predictive maintenance, which is using more and more bandwidth. And so we need to, I will say, offer the, I will say, adequate pipes in order to transport this traffic. So as I mentioned, we are trying to use multiple and various broadband non-safety links, but for sure, we need to use, I will say, some mechanisms in order to, I will say, go fallback retransmission on the safety links, and so also be able to perform the demonstration regarding the performances, the end-to-end performances, in order to ensure the message arrive and go back in due time. So robust monitoring of broadband non-safety links is key, but one point which is very important for me is we do not need to add additional requirement to existing solutions, to existing communication means systems. What we need to do is to define and implement adequate link status, performance regarding the end-to-end aspect, but also regarding the monitoring of the performance to be able to judge in real time if we need to stay on the current link, commercial link, or to go back to the, I will say, safety link. And finally, also, we need to deal with the appropriate security protections, because for sure today, cybersecurity is present everywhere, and we need to protect the communication also, and it's a very important topic, which is, I will say, challenged by airworthiness authorities. So in few words, we need to tackle performances, safety, regulatory, business challenges. And so for me, business case need to be there. If you are not there to, we'll say, propose benefits to the users, typically the airlines, you can forget your marvelous gold system. So really to be business oriented with existing things which are today already used. So comprehensive standardization of key elements. So this is key. So this was already addressed by previous speakers. And early prototyping and validation. So we have launched some, we'll say, activity within CESAR. Next-gen will come for sure. And so for me, we do not need to be too much ambitious. I'm looking for a step-by-step and local or regional deployment for the performance demonstration. Last message I would like to pass to you is that we have different life cycle. And for me, life cycle is key in this, I will say, adventure. So we need to be ready, because if we take 10 years to make the definition, the standardization, plus 10 years to make the implementation, it will be useless. So we need really to be quick in order to offer something which will be easy implementable at aircraft level, knowing that, as explained by Tim, regarding the retrofit aspect to be considered if we want to, I will say, maximize the return of investment and the benefits of the hyper-connected ATM challenges. So this is what I would like to summarize. It's, I will say, simple concept, but I think we need time to implement it, but not too much time. So this is a key part of this white paper in order to try to, we'll say, draw some tracks to follow, to be able to define what are the best solutions. Thank you, Peter. The floor is yours again.
Thanks, Claude. So on that slide just in front of me right now, I see the date 2027. And so there's obviously a challenging question there. Do you think that really something in aviation can be, you know, this hyper-connected ATM, which is currently at TRL2, can we really get there by 2027? And if so, what do we need to change to make that happen?
So as already addressed by Tim and Steve, so for me, we need to make demonstrators at a large scale in order to be able to show that we are capable to achieve the foreseen performances. And so we need to be quick. Again, 2027 is tomorrow. And so for me, the only means to try to show that something is working is to demonstrate it on large scale. Too often we are limited, the demonstrator, on a couple of aircraft, which is not enough representing of the real life and real operations. So.
Okay, and so also with the hyperconnected, you've got this combination of safety and non-safety links and different spectrum. Do you see any particular challenges there with the use of the non-safety related links? You know, could that undermine anything as we go, or we think we've got that under control right now?
For me, we not need to mix things. So for me, safety spectrum is key, and as such must remain clearly. The use of non-safety data links, once the performance will be demonstrated, will help in offloading the data link traffic. And as I mentioned, this traffic is growing very fast due to recent applications such as predictive maintenance or engine monitorings, which are really resource intensive. If you have a look on the recent aircraft program, we multiply by 10 at least the traffic which is offloaded by this kind of aircraft. So we need really to find a solution to offload and to find bandwidth. So for me, the challenge is more or less on the performance monitoring mechanisms, typically the link status, the security protections, and obviously the fallback retransmission. And such as concept like virtual overlay radio mechanisms will be the masterpiece. So we do not need to miss the real target. For me, the debate is not spectrum safety, non-spectrum safety, but it's really the possible performances which are achievable with the commercial links.
Okay. And just coming back to this implementation across a very large number of organizations, just looking in just Europe alone, we've got many ANSPs. What would you think is critical to achieve this coordinated deployment, both in the air on your side but also on the ground? Because we've been caught out by not having things in place between air and ground at the right time. What's your thoughts on that?
Yes, for me, this will be part of the standardization process, and obviously, it is obvious for me that service and the satellite providers, for example, must be fully involved since the beginning to ensure a coordinated deployment, and not only, I will say, a local or regional one like Europe, but worldwide one, because for me, the interop is a key asset. We need to find, I will say, common solutions which will be deployed everywhere. And so the driver, as mentioned by also, again, a previous speaker, is to find the right way to standardize things, because standardizing on one aspect will avoid to have proprietary solutions, but also will help in, I will say, defining common interfaces, protocol, validation, demonstration, in order to ensure that we have the same view on the demonstration and the performances. So for me, clearly, main player and all stakeholders must be around the tables in order to ensure we share all the activity.
Mm-hmm. Absolutely. So it's a good moment just to invite everyone else back to the floor, just so that we can see everybody, because I want to tackle also a few questions that have come up from the audience. There's one which is kind of like a fairly straightforward, just says, why don't you just extend fans globally and then you skip using triple stack and B2 setup? So question, who'd like to pick that one up?
Well, let me say that, are we talking, if we're talking fans, are we talking ACARs? One is that ACARs is a bandwidth hog. It's, if you really want to get into an IPS at some point. Fans messaging, does it do everything that B2 does? No. It had advantages for us in the United States for early adoption domestically, but it really shouldn't have to be fans versus the ATM message set going forward. People spend years, God, I'm thinking, I know we're working on B2 in 2007. So, I mean, we spent years crafting a richer data set, which will support more advanced operations. And fans doesn't support some of the advanced operations. But for those operations we currently are supporting with fans, we should be able to support ATM aircraft in the same airspace without having to even have our controllers know what is being done. So fans is everywhere in the world. The question is do you want to get to the more advanced, and do we want to get to a single airframe or a single platform on an airframe? And I think that's where you kind of want to be. You don't want aircraft that have to do multiple protocols and multiple messages. So, and we're moving on from fans in many places of the world, so you can't say let's freeze it. So I think that that's why we're looking for a solid transition and not going miracles will happen.
So I think, Claude, you're already in ATN B1 across the Airbus fleets. Is that correct? I know we were talking also in meetings this morning in Europe about ATN B2 message set and everything. So we're well progressing on that, but I think you're already at the B1.
Yeah, absolutely. Yeah, we are. Yeah.
Yeah. And I think the point Steve was making is really important as well, that and it relates to another question that's in the Q&A. while this is a presentation about datalink, you shouldn't assume that we're having this discussion and conversation around datalink because all of us are invested in datalink and we need to keep ourselves busy with datalink. It's doing it in support of operations and advanced applications, which we know are coming. That many of the concepts are matured, and the current capabilities, infrastructure, isn't able to deliver the service that's required. So that's a really important point, that it's we are in this discussion trying to respond to the users and customer need, and how we can best do this in the most sustainable way, and that it works for operators from now through into the future. Tim, do you want to comment from a Boeing point of view, how you see the changing applications and how that would affect things from your customers' side?
I think it's inevitable that things are going to continue to evolve. Technology evolves. Things will become obsolete and just unsustainable after after a certain period of time. So what we really need is to have a planned evolution, and also to build our systems going forward as flexible as we can, so that they can adapt and evolve without having these major steps in standards changes and equipage to aircraft and so forth. So I sympathize with some of Tom Emmerich's questions here about why don't we just stick with fans globally and get as much as we can out of that. And I sympathize, or I resonate to that message from the standpoint of let's get as much benefit as we can out of the fans equipped aircraft that are out there, but we do need to prepare for the future where the infrastructure just won't support the spectrum available, and the infrastructure just won't support the massive amount of data that we'll have to have. I also resonate with some of Tom's questions, reading between the lines, that we should be focusing more on the operational paradigms and deriving the suitability of comm systems from those, rather than the tail wagging the dog by saying, hey, we're going to have broadband data, what can we do with it? So I wish the standards organizations would focus a little more at the high level operational concept vision. I understand we have B2, and it's a certain set of applications that people believe are going to be beneficial. It's probably not an exhaustive set. And speaking from experience, when we implemented fans back in the 90s, the way fans actually delivered operational benefits a decade or more later was not what we had envisioned in the beginning. It wasn't the killer app that we had originally thought that enabled the operators to reap benefits from all the investment they made in SATCOM and so forth, and GPS for that matter.
Yeah, thanks. And I think Steve also, we were talking previously about TBO, so trajectory-based operations. This is one of the new operating concepts which datalink will clearly need to support. But there are quite some promising results from work you're referring to in Asia, wasn't there? So can you just summarize that for us?
Yeah, we did what we called a multi-region TBO, where we actually showed it with the exchange of information between the air flight deck and the ground, but mostly between the service providers. We actually could get better trajectories end to end. I think that, and that works well in the ocean. I think that one of the things we know in the United States is that while we started with Datacom as a CPDLC, a controller pilot data link, and was going to make it easier, get more productivity. In the end, it really is about those more complex clearances. And I always like to point out to people that the rule is, if you got more than 7 pieces of information in a voice message, it's not going to go through. With Datacom, you don't have that limitation. So there are a lot of TBO concepts where we would like to give a more complex clearance, a better route path that you can, and make it a one-time thing rather than try to get the controller to go back 4 or 5 times and do things incrementally. And that's where you lose all your efficiencies. So using the route methods strategically is really where we have to go. And that's why we see Datacom as a key link to future TBO operations. You can do initial with voice, but you're always limited to how much change you can make with every voice message.
I think from what I've seen from results from there, that there's been quite a significant contribution to an environmental benefit as well by using the TBO operations, which again is very topical right now and it shouldn't be ignored.
Yeah, and like I said before, if you stick with voice, you're going to get incremental benefit. If you can do a more complex clearances, better route changes, you can get much more efficient, and you'll be able to get higher sustainability goal measures. It helps you get towards your zero in 2050.
Yeah. So within the limited time we've got, I think we showed that there are some applications for the data link, that it's not just here to do it for its own sake. I think that's really important. There was one question about sequencing and planning, which was an observation on the white paper, which is raised in a question about the role of LDACs. And it's referring to your slide, Claude, where the hyperconnected, or the COTS, is seen as the main pillar, but wouldn't the LDACs be foreseen to be as a matured, promising technology, especially regarding the capabilities that it could offer? So that's, in summary, the question. Claude, do you want to come back to that one first?
Yeah, okay. In fact, if I well understand, you want the cheese and the cake. Okay. No, LDACs was part of the white paper, definitely, because it is considered as also as an additional communication means, maybe in the future usable for nav and surveillance purposes or applications. Difficulty with LDACs on the short term is that LDACs is on the table since a long time, still not deployed. It will require terrestrial base station. So in terms of timing, not sure that the LDACs could be there, I will say, as we are looking for hyperconnected ATM, because with hyperconnected ATM, the intent is really to use existing solutions which are in place, communication means which are in place. For LDACs, we are, I will say, starting from scratch. We need to make installation on board the aircraft with a completely new system to connect it. So you know, as aircraft modification are painful. But again, LDACs is not forgotten. LDACs is part of the vision of the roadmap. Not sure that LDACs has the same, I will say, advantages and again benefit and business cases that we are also looking again for the users.
Thanks, Claude. I think in summary, I'd say the discussion is still ongoing. You know, so the white paper is a way of thinking and triggering discussion on this subject, which is exactly what we've been doing today. So I'd certainly like to thank all of my panelists today for their very insightful interventions, and I hope that everyone online has enjoyed the discussion as much as I have, and I'd like to thank them very much. And now hand back to Terry. Over to you, Terry.
Hey, great job, gentlemen. I think y'all just really articulated what was said in our previous session, and that the white paper is a great starting point. But there's a lot of more work that has to get done to get to that implementation phase, coordinating with some of the ongoing work, whether it's at CESAR, NextGen, ICAO, and including all the stakeholders, not just the standards organizations, but manufacturers, operators, and a whole host of others. So Peter, thank you so much for moderating the panel. Peter Hodem from CESAR, Claude Pichon from Airbus, Tim Murphy from Boeing, and Steve Bradford from the FAA. Thank you all for a great session on the implementation piece. I want to take just a moment before we take a short break, thank our sponsors, the Airline Pilots Association and L3 Harris, who graciously sponsored this event for us today. Want to remind everyone that the recording of these sessions are going to be available in the events lobby through November 24th, so you can go back and listen to them if you would like to. Presentation slides are going to also be posted in the events lobby later today. And we do have some on-demand sessions that we pre-recorded prior to today that you can access through www.rtca.org/events. And we've got some pre-recorded sessions from Special Committee 206 and Working Group 75 on aeronautical information and meteorological data link services, SC 214, Working Group 78 and Working Group 92 on standards for air traffic data communication services, Special Committee 216, Working Group 72 on aeronautical information system security, and Special Committee 223, Working Group 108 on the Internet Protocol Suites, IPS and Aeromax. So again, thanks for everyone for joining this session. Invite you all to join us in the next session on the importance of security considerations, and you can get to that next session by going to the events lobby and clicking on the join the session, and we're going to begin that session at the top of the hour. So we'll see you over there. Thank you.